So we move immediately to keynote lecture 2, and I'm very pleased. I see a young couple here. The keynote lecture 2 is devoted to the very first authorized and already in progress as far as technical construction, erection is concerned. The technical part has been also concluded. First offshore wind farm in the whole Mediterranean area. And that will be in the Bay of Taranto, immediately in front of the port, as Mr. Alessandro Severini, the son of Dr. Luigi Severini, who unfortunately for a conflicting duty could not be with us, and apologize for that. And the colleague, his name? Sarah, that will complement the presentation of the office of Mr. Severini, and the floor goes to you for half an hour. Yes, sure. Yeah. Thank you very much.
So, good morning to all present. We have a little delay. We can try to do a marathon. The second one, because the first one is this project in Italy. So, as someone knows, engineer Luigi Severini, the creator and designer of this offshore wind farm in the harbor of Taranto, will be not here today. I will read a short letter written by him. Dear all, unfortunately, due to the imperative commitments, also the importance of the event, and considering my direct interest, I am unable to participate. I am truly sorry I cannot be with you. I wish you a good and fruitful continuation. I send you my regards. I am available to answer your question. Please send me an email at windfarm@studioseverini.it. So, we can start with our presentation. I'm Alessandro Severini, I'm a mechanical engineer, and my colleague L.Severini, she is a civil engineer, and we have developed the geotechnical analysis, the structural solution and calculation in collaboration with other engineers from Studio Severini and NICE Technology. The unexpected absence of Mr. Severini forced us to modify our presentation in a very short time. As a result, we will not dwell on the complex approval process, the organization of the project, and the market research required since 2008 to make possible the realization of this project. We have just some slides on this focus, like a summary. We will focus our presentation on two technical points, the study of the interaction soil and foundation factor, and the mechanical optimization of the foundation and the secondary steel. So I can give the floor to Sarah. Yes.
So good morning. First of all, just an introduction. The wind is used to create clean and inexhaustible energy without producing pollution and emissions in the atmosphere, and always respecting all the standards provided by Horizon 2020 and Sustainable Development Goals. Especially the offshore wind energy as a highly potential sector for Italy. And in fact, between 2006 and 2017, about 20 ideas have been presented, but just one has received all the authorization from local, regional, and national authorities. And it took a long period of time and a difficult bureaucracy. In this kind of slide, we can see the design of the wind farm. This is the future wind farm that we realize in the harbor of Taranto, in the port of Taranto, in the Apulia region, in the south of Italy. And in this image we can see the position of the 10 twin towers. The first 4 twin towers will be located near the quay, and the other 6 will be located near the breakwater. So here and here. Then, okay. Here I want to focus not only the position of the wind tower, but also all the area where we realize the wind farm. In fact, we don't have only the terminal container port of Taranto, but we have also an area highly industrialized. In fact, we have Ilva, that basically is a steel mill, and then we have an ex-yard of Bellevi company that now is dismissed. And we have also Eni refinery. You know Eni, and it's an oil and gas company, so this area is highly polluted. There is an high level of dioxin pollution, and we have also a high level of blood cancer, especially in children. So, if we see all the layouts, this is photo editing obviously, we can see the good impact also in the view and the skyline of this kind of installation. In fact, we have the positive evaluation of MIBAC. MIBAC is the Ministry of Culture and Tourism. That said that this kind of installation will affect in a positive way not only the industrial part but also the commerce and the view and the skyline, obviously, because this is an area with a lot of industry, so this can affect in a good way. Then we can see very briefly all the bureaucratic procedure, because the state of property concession of the project area has been formally requested to the MIT on 2009, but during this period we have a long period of time, and during this period of time we had other requests, other authorization, the environmental competence degree and autorizzazione unica for the construction and the operation of the plant. But after obtaining this authorization, the state of property concession has been granted in 2016. So now the presentation is focused on the technical part of the project, because L.Severini, with nice technology, designed the foundation of the wind farm, of the wind tower. First of all, I want to start with the depth of the seabed, because here, where is the first 4 wind turbine, the depth of the seabed is around 3.76 meters, and here the depth is around 12-18 meters. Then we did a lot of geotechnical analysis, a lot of investigation on site, and also laboratory analysis to extract geophysical and geotechnical data for the characterization of the soil. And the investigation were sub-bottom profiler for the lithostratigraphy of the soil under the seabed. Then, as we can see here, and the digital terrain model, that is obviously a 2D model for the altimetric view of the seabed. Then we have a multi-beam analysis for the morphology of the seabed. And then we have obviously the laboratory analysis. because we took 50 samples from each vertical, or from each investigated vertical. The vertical coincides with the position of the 10 wind turbines. So we took 5 samples from each vertical, so the total number was 50. And then we have a lot of laboratory analysis from the geophysical part. We have granulometry, affable limits, initial body index, unit weight, saturated unit weight, and so on, and also the geotechnical tests that were triaxial tests, cycling triaxial tests, odometric tests, and directing cutting tests. So here we can see the stratigraphy of the soil, and basically the soil is an over-consolidated clay. It's an over-consolidated blue-gray clay, and in general there are not many wind farms, offshore wind farms with this kind of soil. This is more complex to know, for the elaboration of the data, for the simulation that we have done. It's complex to extrapolate the representative geophysical and geotechnical data for the simulation that we have done for the interaction of foundation and soil. And then, this is the samples, you know. Okay. Okay, these are the design tools that we have used. We've done a lot of simulation. We have done static and dynamic simulation, modal chronological simulation with SolidWorks. We have done geotechnical simulation with MIDAS, GTS, and X. We extrapolate PY curves from Alpine. And we did the drivability analysis for the choose of the hammer that will pile the foundation. So this is the MIDAS and the model that we did with MIDAS. This is the soil. The soil is a solid object inside MIDAS, and then we did this. This is the water table, and then we did also the model of the monopile, that is a shell element. The mesh is an hybrid mesh, and what is important to know is the model of the soil, because we choose the constitutive model, and we put inside MIDAS the geophysical and geotechnical data required by this model. But how we choose this data? We follow the rule, the standard of WINERCOST'18, 7, and we follow the percentile rule for extract the representative geophysical and geotechnical data for the soil, and then in MIDAS we perform, this is the monopile, and this is the hole from the passage of the electrical cable, and then we can see, okay, this is how we perform the analysis, and this is just results from our analysis. But what we done? We follow the NTC 2008 standards that are basically national standards. We use IEC international standards, to perform ultimate state limit analysis, to perform operating state limit analysis, and to perform seismic analysis. And basically the aim of this analysis is to know if this system, the foundation and the soil, works subject to this kind of load that are transmitted by the wind tower to the foundation. And it works. There are not plastic surface, there are not breaking wedges, there are not breaking surface. So we can go on. These are the deformation of the soil. This is the deformation of the soil, of the seabed, basically. So we perform also a drivability analysis with GRL WIP to choose the system that in the operative part, in the first step of the installation of this wind farm, we perform the driving of the pile to the final depth into the soil. And with GRL WIP, we choose an integrated system with two kinds of items: a vibro driver, that is this, a vibro driver and an hammer. But why? Why there is an integrated system? Why we don't choose only the hammer? Because there is a limitation for the noise in the site. So we cannot use only the hammer because it produces a lot of noise. So we choose for the first part of the drivability, we perform it with a vibro hammer that has a high frequency. And then the vibro hammer arrives to a depth of 15 meters. And then to the final depth we perform the drivability analysis with a hammer. But what have we done? We done a simulation analysis of this kind of part of the drivability analysis in SolidWorks, because we want to know if the monopile subjected to vibro and hammering loads, and especially the flange, the bolted flange that is on the top, or it's at the edge of the monopile. We want to know if it will be overstressed, and this is the result, and we are not we were not encountered this kind. There are not overstresses because the von Mises stress are below the maximum value. So this is also in SolidWorks, also the drivability analysis we want to know if this kind of element that is the oil from the passage of the electrical cable inside the monopiles would be overstressed. It is not. So obviously also the vertical tolerance is good. It remains below the maximum vertical error, that is 0.5 degree. And then, then we can briefly talk about the wind turbine. That the wind turbine was designed by Senvion, not by us. And in this table we can see all the value regarding the wind turbine, you know the math. So the tower, tower length, safety factor, and so on. Senvion will provide 10 turbines. Each turbine has a power of 3 megawatt. So the wind farm will be of 30 megawatt. This is briefly the Meteorson studies regarding
the rotor diameter?
120.
120.
Regarding the Meteorson study. This is basically the data used by Senvion to design the wind turbine. So the main direction, the wave spectra, the extreme wave, and the peak period, the return period of 50 years, and so on. So we also protect the base of the monopile, because we want to mitigate the erosion phenomena around the monopiles. So there is a score protection system that basically is formed of several number of concrete cubicles. This is a matrices, and this matrices is put around the monopiles and also is put on the electrical cable, on the submarine electrical cable to protect the electrical cable. In fact, we can see here around the monopiles, these matrices, here and here, and above the electrical cable, here, the matrices. So now I give the floor to Alessandro.
Thank you, Sarah.
Thank you.
So now we can start the description of the structural sizing. At the first time we did a pre-dimension of the monopiles, and we start with the soil characterization in a double dimension software. The software is L.Severini. The first sizing starts with some fixed point, for example the diameter of the monopile, 4.5 meters, the specific soil data for each monopile, the step between one steel shell and the next one, and this step is 5 mm according to international wells rules. The type of grade of steel has 355 ml from European standard norms, and the loads for calculation at the first time the loads were from Vestas V90 turbine. L.Severini have a lot of different soil model, API soft clay, stiff clay model, liquefied sand, and so many other. And for each model it's possible to choose a lot of different coefficients. We checked some of these models with discussion on which is the best, or better, which one fit better in our soil, and anyway, with the first design in L.Severini, a bit raw, we could make the modifications of the monopile, the thickness of the wall, the total length, the length of single steel shell. With this first design, we made a 3D model in SolidWorks, and we did the simulation with the Winkler springs to simulate the soil effect. The preliminary 3D sizing was done, and we gradually analyzed every critical point, wells, marine cable holes, and this is a screen of the mesh, and the thickness and the junction. And not secondary goals during the design was the optimization of the cutting plan to reduce cost of raw material and waste and wells. We did it, and this operation has been possible just with accurate simulation with finite element analysis. So in this picture, you can see the flange of tower base of one supplier. You can see the small radius near the neck of the flange. And this is a review of our flange with the radius of 40 millimeters. This is important because our project have not the transition piece and have a direct mount to monopile and tower. And now we can see the result of hammering simulation, like the picture of SAR, with stress result and mesh. It's not last review, but I put this image because it is very clear the stress during the hammering. And this is another simulation with the stress near the neck of the flange. So during the review, the design of monopile changed, not a lot, but this evolution is due to, for example, the different provider of turbine, the solution for marine cable entrance. For example, this is the old solution with the external J2 in red, and this is the last solution with the sealing system and the internal J2. The dimension and solution for the platform, this is a steel and concrete platform, the old one, and this is a totally steel platform with grating system. We have the internal, we modified the internal platform, and this is the final solution. So this project hasn't been simple. You know, a lot of activity in this kind of project are not consequential, but contemporary and iterative. But we did it, and Studio Severini, with the support of nice technology, has managed and fully carried out all the activities necessary for complete realization of this project. Bureaucracy procedure, formulation design, power transmission and grid design, structural and geotechnical checkup. The goal for the future is to focus the research on development of other wind technology, more suitable for Mediterranean wind and wave condition. For example, the floating turbine and the cinematic race system. Thank you for your attention. If you have any question, you can use
Yes,
contact.
thank you. Thank you. There are for sure questions because you are the pilot, you are the heroes
Yes.
of offshore wind energy in the Mediterranean area, which I remind you, if you measure the cost and exclude the Black Sea, it's approximately 16,000 kilometers. So it's a little bit to exploit in terms of wind energy. So these are the addresses. This was the Luigi, the manager, and then Alessandro and Sara. Okay, there was a hand stretch.
Just a question. I've realised that you put 4 wind turbines near the pier.
Yeah.
Can you repeat?
You put 4 wind turbines near the pier and the other
Yes.
in deeper water. So why was that decision?
This decision is a strategic decision because yes, we know that the seabed, we have not very depth sea, but the decision is because for authorization and for the image of the wind farm was I think the best solution for
More suitable.
yes.
In landscape, I think Alessandro mentioned very well, this area in Taranto is possibly the most industrialized formerly, because Ilva is the largest steel producer in Europe. There is no such a large industrial compound in Germany. Not comparable. It's 10 times larger than the largest one.
If
So,
you take
but
a
it's-
picture with
It is
Google,
old, it is
it's
not
like a wall.
well in shape. So this is a measure of revitalizing and rehabilitating a very bad industrial area. Lot of environmental problems.
Yes.
So,
And of course there is the cost of electrical cable. This is not a real offshore wind farm, it's a near offshore, and this is another point
yeah.
for this decision.
Offshore, close to shore.
Close to shore. Yes.
Okay, any other question? Please, Laura.
Do you have here in Taranto or in Mediterranean the offshore infrastructure with this kind of hammers?
So, Sarah? There is the hammer technology are not Italian. There are a lot of supplier industry in Europe and in North America, but no one in no one. No. And this is a very big opportunity for Italian industry to create a very big net and new work in this field.
Another question?
Yeah,
You have been talking
only
about,
one more.
yeah,
And
you
then
have been
Professor
talking
Bosco,
about
please.
the fatigue impact of the hammering process.
Yes.
Do you have an idea how big the tree damage from the hammering process in your case was? The tree damage. So you have been calculating a damage from the hammering process.
Yes.
Yes,
exactly.
we did a model chronological analysis in SolidWorks. Yes. We simulated
What
the...
was the amount of the
We have no damage because we have another flange just for hammering because we have not the direct mount on our flange, and to reduce the stress on the monopile flange we put another flange just for the clamp of a vibro hammer and for the cap.
The anvil.
Yes, of the vibro.
We have an opposite flange.
Okay.
We have another flange.
Okay.
To prevent the damage, basically.
Yeah. The, you know, there is in Italy there is the law of the pasta asciutta. You cannot. I promised to Daniela that at 15 we will be out of the room. So I would allow now a question from a geotechnical guy, because geotechnics plays a very important role in the first Mediterranean offshore wind farm. Giovanni.
Yes, just a couple of questions. I understand that, no, I don't need it. The monopile is hollow. Is it excavated afterwards? You excavate the soil inside it or not?
No.
No. I
Before
understand
the
that
hammering, no.
after.
After,
No.
Okay.
No.
I
There is
understand
soil
that
inside.
soil investigation was carried from a floating barge. Okay. You did a CPT test.
Yeah.
What kind of CPT test you performed? CPT or CPTU?
CPTU.
Okay.
We use...
Yeah. Okay, I think there would be a lot of questions, I think, by Enzo. I don't see Enzo Marino concerning the hydrodynamic model, but I don't put this question now.
Okay.
Simon Tevolde, one short question,
Another one?
but you have to shout or you need a microphone.
Lì sotto, fondo a sinistra.
No, we can't hear you. Wait for the mic. No?
Okay, thank you. It was interesting presentation. You are
Yes.
avoiding the conversation, which I find interesting. You are driving the monopile and connecting the element to the tower. And what about the secondary structure, for example, the ship ladder? Is it connected better or is it connected to the monopile while driving?
The secondary steel
Yeah.
On a monopile after driving installation. Yes.
So you are doing like welding in some kind of conditions?
No, sorry.
Yes, but the elements like the heels for the platform and
Yes, the secondary steel.
You are talking about leather,
Yeah. Yeah.
so secondary
steel.
Okay, so.
The installation of secondary steel platform, bumper, and stairs after the hammer.
Transition, please.
No, not transition.
it's not, there is not a transition.
No.
There will be not.
On the monopile, there are just the support for bolting the secondary steel. Some flange. I don't know if I have a picture.
No time for pictures now. We are 1 minute late, and Daniela will be worried.
Just so much. Okay. This one. Just a second. Just a second. For this. Okay. Something like this. Okay. And on this support, we put the secondary steel, the platform.
So it doesn't have any contact, it's only by friction.
Okay, thank you. Any other question during the lunch or after lunch?